Dimensional analysis, short calculation. Derivation of the centripetal force formula. Statement of the problem. To keep an object moving in a circle at constant speed requires a net force, known as centripetal force. Using dimensional analysis, find the expression of the centripetal force. Solution. To start, we ask, on which mechanical variables could the centripetal force F depend? The moving object has only three characteristics which are likely to enter the formula. Its mass m, its speed v, and the radius r of its circular path. Apart from a dimensionless constant, the centripetal force F must therefore be given by an equation of the form F equals m to a times v to b times r to c, with a, b, and c numerical exponents to be determined. Switching to dimensions, we write dimension of F equals dimension of m to a times dimension of v to b times dimension of r to c, or m times L over square t equals m to a times L over t, all raised to b, times L to c. After simplifying, m times L times t to minus 2 equals m to a times L raised to b plus c times t to minus b. The fundamental dimensions must be the same on each side. Therefore, equating the exponents, we find the values of the constants a, b, and c. More precisely, a equals 1, b equals 2, and c equals minus 1. When these values are used in the original equation, we recover the well-known equation for the centripetal force F equals m times v squared over r. Although dimensional analysis gives us the exact dependence on the mechanical variables, a possible dimensionless factor c cannot be excluded. In this case, it is a happy coincidence that the constant c happens to be 1. And with the last comment, we have concluded this quick example on the use of dimensional analysis. I hope you liked the problem. If you did, please subscribe to my channel to encourage the creation of more content like this. Thanks a lot for your support.